In this video, we'll finish one very quick idea to finish section 4.4, and then just a few quick words from section 4.5 with a couple of little, just warnings and what to look for. So the first thing, 4.4, we already did a lot. Chebyshev's rule, empirical rule, talking about, again, that idea of the percentage of data that falls within so many standard deviations of the mean. Then we got into the z-score, a way to look at an individual data value and to compare it to the rest of the data set. And the last thing, our book sneaks this in at the bottom of page 179. They just mention it quickly, so let's make sure we get this definition, the idea of a percentile. A percentile is another way to look at an individual data value. So we've seen these things before. If you have kids and you go to the doctor and you talk about their growth and you're told something like your child is in the 40th percentile with regard to height or weight, whatever, or, test exams, your test score, SATs, maybe you may go on, take the GREs, looking for grad school, but especially the SATs, you've seen that. Someone says, I scored in the 75th percentile on the math section. I scored in the 53rd percentile. What do these things mean? You're looking at an individual data value, and the percentile tells you the percentage of the data that specifically falls below that value. So your child's height, you've got a young child, they are now 23 inches tall. If you're told they are in the 40th percentile, that means at 23 inches tall, they are taller than 40% of the other children of that age, which means that they are then shorter than 60%. Similar, your test score. Maybe, thinking of SATs out of 800. Maybe you got a 670 on the math section, a very good score. And you're told that 670 is in the 75th percentile. That means you did better than 75%. You had a higher math score than 75% of the other people that took the SATs. So that's it. That's all it means. If you go back and look at some of our other problems, we can refer to a few things in this same way. So very quickly, just looking at, I'm looking for one of the empirical rule problems. The percentage of runners that ran more than 17.2 miles is 84%. Okay? That means someone who ran 17.2 miles would be in the 84th percentile. That you can kind of go back and forth. That's the idea. But again, all this still, we're looking at numerical data. We're assuming that we've already ordered it. And now, again, this idea of percentile, it always has that idea of falls below that value. So again, similar to z-scores, there are most contexts, most situations better than average. Bigger than average means better. And the same thing here. When you're thinking about percentiles, well, sometimes it's not about better. When you're talking about a child and they're growing, you just want to make sure that everything is okay. That, if they're growing really fast, or maybe if they weigh a real lot, you could look into maybe they have, some other condition that's leading to that, a slow metabolism or just an excessive grow gene. On the other side, if they're on a very low percentile, what's going on? Are they not getting the right nutrition? Is there, again, maybe some other condition leading to them being shorter? But that's the situation. So again, that's our idea, and that's all we need to say about a percentile. Later on, when we get a little deeper with more bell curve problems, we'll see this come up again, and we'll still have that idea of a z-score to work backwards, that we'll be able to find that value. that we'll be able to say it takes this salary to be in the 70th percentile, or this test score to be in the 60th percentile, things of that nature. So that's it. That's the end of 4.4. And 4.5, they always have that little end section just interpreting, communicating results of statistical analyses. So just a couple of things. On page 184, they have a few what to look for in published data, and just a couple of things to realize. So, what are you looking for? Is the chosen summary measure appropriate for the type of data collected? In particular, watch for inappropriate use of mean and standard deviation with categorical data that has been coded numerically. This is where we've talked about be careful with how many questions. There are a lot of situations you get categorical data that we force into a numerical situation, and then those numbers don't quite mean the same thing that they normally would. So that's just a quick thing. Another one, if both the mean and median are reported, how do the values compare? What does this suggest about the distribution? If only the mean or the median was used, is that the appropriate choice? Maybe the other one should have been better. Maybe you're being, there's an attempt to mislead you by only giving you one. Is the standard deviation large or small? Is the value consistent with your expectations? Now that's a tough one. That's why, again, I keep talking about going 2 standard deviations above, 2 below. Does that value make sense? That's one way you can try and tell. But is the value consistent? Does the value of the standard deviation tell you anything? Does that help give you a sense that the data is spread out or the data is consistent? And then they finish, is there anything interesting that can be said by applying Chebyshev or empirical? Which again, just giving you a numerical way to look at a range and have a sense of what proportion, what percentage of data falls between those values. So there's just a few things to look for. And then on the next page, just a little bit of a word to the wise, the cautions, the limitations. I'm not going to read all of them, but just a few that are a little more important. Point number 1. After all of what we've done in chapter 4, there are some students that still just think, well, isn't the mean enough? Doesn't that tell me enough? And the answer is no. Again, everything, the more information we have, the better. Having the mean is better than not having the mean, but it's not enough to tell us everything. And it's not even just the mean and the median. Point number 1 is that measures of center don't tell all. Without additional information about variability or distribution shape, we're very limited by only having the mean or median. And they have a few other good points about distribution shape, but the last few I want to get to are 5, 6, and 7. 5, be careful with box plots based on small sample size. Box plots are really nice, several values that really try and highlight highs, lows, middles, give you a sense of the breakdown, the proportion. But if it's a small sample size, that's another situation where it's easy to overblow the results, to look at something and make massive conclusions, but you really only have a small data set. So that's a little something to be careful with. Number 6, not all distributions are normal or even approximately normal. So people try and apply the empirical rule everywhere, but that's why we have the 2 rules. Chebyshev applies to everything. Empirical only applies if you know the distribution is normal. And then last, number 7, watch out for outliers. How outliers can be problematic. Now, you don't get to ignore them, but to be able to recognize that outliers might be what is throwing off the data. So that's it. Chapter 4 was quite lengthy, but this was just a nice, quick little few things to be careful with. Most of this is really just thinking for yourself, thinking about a real-world application, whereas thinking about, next exam, 4.1 through 4.4, there is a lot of material that will be coming up.